In this video, I'm going to show you the drainage basin for figure 1030. Now, here is this one in the AutoCAD drawing, so you can trace over the top of it and follow the path that I have. Now, this one isn't to scale. When I brought it in, I just scaled it up. I didn't actually draw a scale on it. It's just a figure. But what I do want to show you is, here's the point of analysis. So if we're looking at this, notice how it goes up this ridge line and it comes through here and splits off. If I take a look at this here, you can see that it's cutting through this section here. So they're assuming that a drop of water hits here, it'll roll down this side. Now, the next part of it, it comes through is we've got almost a saddle through here. And you can see all this water drains down to this point, down to this Morgan Creek. So there's a road and the creek follows the road, but the water always goes down to this creek. So we've got Ingle Road, and on the opposite side, we have a drainage swale called Stowell. Now, we're interested in the Morgan Creek drainage basin. So if I look at this, you can see that I'm going perpendicular to these contours. Remember, when the contours are pointing downhill, it's going to be a ridgeline. When the contours are pointing uphill, it's going to be some type of a drainage or valley. Now, you can go ahead and trace the contours over the top of this one, but what is interesting about this project here is that I actually found this project, and it's actually located in New York. If you look at the north arrow, so I rotated this. So I'm going to expand this just to show you. Now, on this example, I'm going to do something different to tell you what the drainage area is. And this will be to scale now because I brought it in, and what I've got here in Civil 3D is a geolocation. And I can actually turn the geolocation just to the aerial. So then on top of it, you can see the aerial map, or I can show you just the road map that's underneath of it. Okay, so I know I'm exactly where I am, and I know I'm to almost perfect to scale, but maybe not, because, you know, I am scaling a picture. But if I look at this, and I've basically shaded this map back, so I'm going to turn this layer on. I've shaded this back, so I'm going to do a transparency of 70 just to show you a little bit more. So you can see where the ridge lines are, and you can see that I'm actually following this creek and road. But what's really interesting, there's a program out there, and it's called StreamStats. So if you look it up online, it's made by the USGS. It's called the StreamStats program. In the first week's class, I told you that we had to have data for where we're discharging to, and that's stream gauge data. Now, to find this information, if I was doing, let's say I go back to my drawing, I needed to find the outlet point. All this water's discharging to this river down here. It's the Tigua River, however you say it. That's how I'm going to say it. But when we tie into it, we have to worry about whether we have existing water that we're tying into, or if it's a free outfall. Since we're tying into a river, we know we have an issue with maybe tailwater, and I'll explain that later. So what I did is I used this stream data. If you click on the interactive map, I went ahead and zoomed into the location. You can use this. Now, what it has is this gauge information. We are extremely interested in the gauge information. Why? Because that tells us what the elevations are of that stream during the times of year, and what the peak elevation in that stream is that we're tying to. So when our water discharges to it, if this was 100, I know that everything's being back, or 1,000, this is all being backed up further into this Morgan Creek stream. Now, what this program allows you to do is you're allowed to pick a point of analysis here. This last one says watershed delineation from a point. So if you look at our map here, it says the point of analysis, here's the river. It's basically right before that road. So I'm going to come back over here. It's right here on the road, and we're interested in this Morgan Creek. So I'm going to go ahead and zoom in. And I'm going to pick a point somewhere over here. So I'm going to click on this, and I'm going to pick basically right there. Now, what that's supposed to do, it says click on the map at the desired location to delineate that. So let me zoom out. So it's waiting. It's doing some calculations for me. See how long this takes. So what it's done is it's created, I went ahead and clicked pause so you wouldn't have to wait for it. It finally created the drainage basin. Now, I want you to take a look at that compared to the basin that they've picked over here. So let me make this a little bit smaller here. Hold on. Now, most important when you're using information that you're not doing yourself, it says be sure to thoroughly check the delineated basin for accuracy before using the information. So the tool that we have, so I'm going to expand this back up. I finally got my map back, and I'm going to go ahead and compute the basin characteristics for it. So it gives me the length, the elevations, slopes, precipitation, all that. So I'm going to go ahead and close that down. It also gives me flow statistics for this. So I can compute the flows based on the creek that I'm looking at, if it's available, if it's gauged or ungauged, meaning that there's actually a stream gauge in there. So the data's come up. So it has characteristics for the basin. So it's got a drainage basin of 2.52 square miles. The stream slope, 10 and 85% method, just tells you how they're assuming the method, and gives you a flow statistics on that. So I'm just going to go ahead and print that out to a PDF and save it for later. Now, I also want to take a look at, while that's doing that, I want to take a look at downloading the information. I can download it as a shapefile and a geodatabase because it can be brought into AutoCAD. So I'm going to bring it down and download it as a shapefile, and I'm also going to bring it down into a geodatabase. So maybe later in the semester I can show you some additional information on how to use the database in it also. I'm going to put that over to the side. Now, it's interesting that it delineated it like that. So I'm going to go ahead and pan this over. And I'm going to go ahead and make that smaller so I can take a look at the two. So when I'm looking at this, I'm going to view, rotate counterclockwise. So basically it looks like this. Notice that it's coming up, and in here it does a little bit different than what's over here. So what this person may have delineated versus what a computer model is actually delineating, don't be surprised. Does it make a big difference? Maybe, maybe not. It comes through here, again, looks a little different, splits this in half. These are looking really similar. So, you know, you feel good about the model itself. Now, up in here where this ridge area is, or this saddle area, they could have done something different. Maybe the contours are older in this picture than they are here. Something might have modified, or somebody's got updated contours. And it still comes through here, and then you can see this point right here is here, and it comes back down. And you can see that it's going through these contours and around how we've delineated also. So I feel pretty good in general about the area of this. So it said that we had a 2.52 square mile. So that means the 2.52 square miles means we have 1,600 and almost 13 acres here. So take a look at the drawing that I've got in here. Remember that I have actually scaled this drawing out. So based on the scale of the object, it may not actually measure that. So, but go ahead and do the delineation and take a look at what the scale of this has been set at, knowing that, and here's something else, when somebody brings a drawing in, you may not have the right scale. So if you have other ways to check the accuracy, do. So if I said, okay, here's my drawing, here's the site, and you just, came in and said, fine, I may have given you, like I've done here, inaccurate scales. So it would be your job to confirm that the scale that the aerial or the topographic map, USGS map, is brought in correctly. Because I've seen that happen where people bring in USGS maps and they're not scaled to the correct size, and then that can cause major problems when you're starting to design. All right, so for this one, go ahead and delineate the basin, figure out what the area is, and compare it to what we got from the stream stats, and that was 2.52 square miles, or 1,600 and almost 13 acres. All right, that's it for this video.